Good morning, sir.
Good morning. Good morning, all. So, last class, that means yesterday, we gave 10 definitions. It was really hard, only definitions in a class. But what I have said, this is somehow a language we have started. That means when you have learned ABCD in class or nursery, it was really difficult. What should we do? This learning this ABCD. But now still we are using this ABCD. Actually, when you have learned ABCD to Z, the remaining part is the only remix. So here also we are doing this remix. Now last class we have just learned 10 definitions. I just quickly repeat and then I am giving one or two examples. Then we are going to discuss about the binomial distribution. That means mainly in your syllabus two distribution, binomial distribution and normal distribution. And parallelly we will discuss at the Poisson distribution. And these three distributions. So today we hope I'll discuss binomial distribution and with some examples. Okay, let's get started. Last class, okay, it's better if we, I have written so many things without showing the written form. If I show here, we have defined random variable. And I hope you know, consider a random experiment with the sample space S, a random experiment x sub zeta. Okay, I should stop my camera because some students don't expect this. Okay, so now this uh, and is a random variable we denoted by x zeta, or generally we denote only x, is a single valued function that assigns a real number called the value of x of zeta or x to its sample space S of S. So we have defined like this way. This is a function from S is a sample space, some any point maps to a real number. That's why x is a subset of R. And now we have defined some other definitions. That means events. That means how we this notation. Basically, we should understand the notation. X equal to x means we take the random variable x, where this is small x is belongs to the capital X. The capital X, we can say that it is a range set. Out of the range, we are taking only x, and that is basically the that means we are getting the all sample space such that we define the random variable x, this x. And if we take put both sides, and this is similar way we have defined the different values. That means if x less than or equal to x, since x is real set subset of real, so we can compare. We were getting any x some value and other value of the capital X, it should be either less than or equal to x or greater than or equal to x. So if we take write like this, x less than or equal to small x, that means all values of the sample space such that whose defined random variable should be less than or equal to this condition set. Similarly this. And if we put both side probability, we are getting this. We have discussed this last class. And we have defined this one, distribution function. So we should remember this one. Cumulative distribution function or distribution function only. Generally, we say that CDF. It is better, whatever distribution function or cumulative distribution, we define CDF. Fx we denoted by, that is actually the probability of x such that x less than or equal to small x. And this x can be any value lie between a real number minus infinity to infinity. And we have defined another four definitions here that determination of the probability. Okay, this is the we have defined determination of probability. This is not the definition, and this is the limiting case, whatever we have discussed. And here these four definitions, that means discrete random variable and probability mass function. I hope you are able to remember that. And keep in mind that the random variable can be discrete or maybe continuous. So that depend on the function. That means if we consider x and f of x versus fxx. This, if this function is continuous, then we call the continuous random variable. If this function is discontinuous, that means discrete, then we call discrete random variable, something like this. And similarly, if it is discrete, then we define the graph should be like this. That means the curve of the graph should be discontinuous. And then we define the probability mass function. Mass function means in between some values. That means it is fixed. That means here you see if this random variable are x1, x2, xn, or it is finite or infinite, but it is countable. That means if it is finite, finite countable, or if it is infinite, infinitely countable, countably infinite number. Then we can define like this: if xi minus if xi minus 1 is actually, we are defining the, we are taking, if we think as a graph. Okay, let me just. If we think something like this graph, and so here we are taking, so this is xi, and this is xi, and this is xi minus 1. So we are taking from here to probability up to this, and then we are just subtracting up to this one. So something like, so we are getting basically this portion, the probability, something like this. So this minus this, we are just defining probability of this one, and so this portion equal to, we are denoted by px of x, probability mass function, probability mass function of the random variable x equal to x, this point. So we denoted it is PMF, probability mass function. And similarly, we have defined this continuous random variable and probability density function. So when it is continuous, we generally say the density, and when it is discrete, we call it as mass. So this is random variable we have defined, and we have, in continuous case, we have shown that some, for particular point, this random variable may not be 0, but the probability may be 0. So it is in continuous case it is, and the density function is only the derivative of this function. That means derivative of this f of x, and it is denoted by small fx. We have defined this one, and yeah, we have defined this mean, means average, and moment. We have defined this, and variance, and standard deviation. These 4 definitions. So let us just check out again. This mean means we have defined just taking average, or divided, it is average means it should be divided by something, divided by actually summation of all probabilities, and that is 1. So we are not written the lower part. And similarly, if it is continuous, then we divided by all probabilities, that is actually 1 again. So only the above part, the weight into the probability. That means the random variable into the probability of that point, multiplying, and then summation for all k, all the point xi. That's where just the average or mean continuous cases. And movement, that means if we just increase the values of the random variable, that means change the random with some weight, then this is the movement, a similar definition actually only. And variance means how far from the original one, that means mean means average one. So this is average, and variance is, we are defining like this, varx.
Sir,
We did not, yes, please.
so there is written that the mean of the x is the first moment of x. What does it mean?
Actually, this one. That means here, if you take x equal to 1, you are getting the previous equation, previous one. So first means the n equal to 1 and n equal to 2, you are getting the different thing. Okay.
So is that there any relation between that
Is there any? What?
moment to mean?
Sorry.
Any relation between moment and mean?
Is, no, actually, moment. No, last actually yesterday's class, someone asked after finishing the class. So why we are taking this n moment? That means you see, just random variable we are defining from the probably the sample space to a real number, and this real number can be defined anyway. So here, not generally there is some common rule, but we don't. If we don't follow that rule, that is also true. So here you see this xi is actually from the real number. And whatever, suppose it is taken some point wise, x1, x2, xn, and we are just increasing. That means if it is greater than 1, that means all values of xi is greater than 1, then when we are powering, that means it is this real number gap is going to more. Are you getting it? So if you see, for example, in random number somewhere, suppose 1, 2, 3, 4, 5. And if we take the first momentum, that means power is 1, then we are getting 1 into some probability, that means at the point that probability. And 2 into at the point that probability of 2, we can say something like this. And 3 into probability of 3, or 4 into probability of 4, say. But if we increase this power, that means 1 to the power, suppose 2 only. 1 square into probability of 1, 2 square into probability of 2, 3 square into probability of 3. That means this real number distribution is going to, that means somehow light. That means 1 goes to 1 and 2 goes to 4, and 3 goes to 9, like this. So this random variable we are expanding. That's actually we are saying. So momentum. Are you getting in my hand? So here
Yes,
what I
sir.
am want to say, this is 1, 2, 3, 4, like this. And if we increase the power, this graph is converted to 1, this 1 goes to here, fine. And this 2 goes to somewhere in the position 4. So we are finding the probability is this point. And similarly 3 goes to 9 position. So we need to do it. So this is, you are somehow expanding the real numbers. That's actually the momentum. I hope you are
Excuse me,
getting.
sir.
Huh? Yes.
Sir, in the definition of mean,
Mm-hmm.
uh, uh, sir, in it is given that E of x equal to summation over k x k p k of x k. So you have told that by 1. Can you explain it once again? Sorry for disturbing you.
No, no. So what is your question? You should ask. Proof.
Sir, mean the formula for a discrete
I
or
got it. This mean.
sir, you told na that divided by 1.
Mm-hmm.
So how it is by 1? Can you please?
Oh, okay, okay. Just yeah. So what I want to say it. So for example, suppose in your in class you have 10 students in class, and suppose you are finding the average age. What we do? We just add the all ages out of these 10 students. Suppose in year. And if we divide it by 10, we are getting the averages. Fine. And here this mean is actually we are defining like this way. Xi summation over xi into p of px of xi divided by summation over p of xi. That means average means we should be x of xi. The average means we should divide with something. That means we should do some average. Means average here. But here we are below we are adding all probabilities, and we know that in a sample space with all probabilities, summation of all probabilities, it should be 1. So this portion is goes to 1. In this case, whatever I gave the example, it is actually some year of ages uh, divided by 10. In this case, it is not the 1, but in this case, it is 1. That is the summation. That's why below part is not written. Okay.
Okay, sir. Thank you, sir.
Sir, I have understood the definition and all, sir, but how, what is the meaning significance of this, sir? That cannot I understand.
Okay, okay. Wait. I hope you will get some idea. You need some time. Actually, we are learning ABCD only. So, and it is difficult actually within 6 classes. That means I have to finish within 2 classes, another 2 classes. So this, your questions are valid, I agree. And it's actually difficult to answer all questions. Some questions may not be, I have not known probably, but some almost all questions I know actually. So whatever you are asking, but it is difficult to realization within this short time. So those who are interested, basically you read. I have not said you may read the book Baburam. It is nicely written. All of these questions, answer of these questions, you can get it. But still, I'll try to answer And some note of here I have written from Baburam, so you can get from there. And Baburam you can download also, whatever, for somewhere else. Okay, so let us get some flavor to get some flavor your question actually. Why? So actually some question is something like this. You are learning ABCD in nursery, and if someone asks that why we learn this ABCD, what is the significance of these symbols? So it needs some time basically. Right. Okay, so let us try to solve this example. Anyone able to understand this question and try to solve? I am giving 1 minute to read it. This example 1.
Yes, sir. K is
Solution.
equal to 0.1, sir.
Huh?
K is equal to 0.1.
A random variable x has the following probability function. X
Yes,
equal
sir.
to this. So this is suppose given. Huh? X means here actually it should be, it is better if we write capital X. Capital X means it is a random variable, -2, -2, -1, 0, 1, 2, 3, and corresponding that point, the probability distribution is for random variable -2, the probability is 0.1, probability of that one, and random variable x -1 is k, 0 is -2, and 1, and suppose these all the sample spaces. Then what is the value of k? How can we find it?
0.1, sir.
Summation of
Px is equal
px
to 1.
equals to 1.
Yes, sir. Summation of px equal to 1.
Yeah,
Yes, sir.
exactly. Summation of whatever I've said just immediately. Summation of the px should be 1. That means all pi. Then we know that if we know that all sample spaces whose probability, if we adds all the probabilities, it will be 1. So that's it is done. So if we summation of all probabilities and we are adding and calculating, what we are getting 0. What is the value of k?
0.1.
0.1.
0.1, sir.
0.1. Yeah. So results k equal to 0.1. Good. And now the second question is
0.8, sir.
calculate the mean and variance. So you see this question can come in your exam. To do this, first part is fine, and second part you need to remember what is the mean and what is the variance. You just previously learned that mean means the sum average of this one, that means
Summation of xi into pxi.
yeah, summation of xi into pi. That means this -2 into this -2 into into 0.1 plus -1 into k value of k already you have found 0.1. So -1 into 0.1, 0 into 0.2, 1 into 0.2, 2 into 0.3, and 3 into 0.1. After adding this, so we did this one. Yeah, this is the formula found. This is the mu, and we know that mu we denoted by mu or e of x. So both notation interchangeably will use. So after calculating, we are getting this. Is it fine? Now, what is the variance? Anyone able to calculate this variance?
Yes, sir.
I'm giving 1 minute again. You try.
Sir,
Mm-hmm.
sir, is it possible that mean is greater than 1?
Mean is yeah,
Greater than 1.
yeah, it can be happen.
Okay, sir.
It can be happen. For example, this one. So I've said that random variable we can define anywhere. If this random variable change, suppose this is 1, that means this -1, 2 is we are defining 1, this is 2, this is 3, this is 4, this is 5, this is 6. And then if we apply the mean, then it will by default it will go all positive. And you see we are multiplying 3 into something like this, it is positively goes to greater than 1. Mean can go greater than 1. Mean is not somehow related to probability, but it is also related to random variable. That's why it can be greater than 1.
Sir, I thought that mean is a probability mean.
Or no, it is actually it is mean is not only the probability of mean, that means it is associated with random variable also.
Sir,
We are
is the
coming.
answer 0.8?
Example probably we are coming. You just try to solve this one variance. What is variance? Anyone trying?
Sir, 2.16.
Yes, sir.
Yes,
The
2.16.
answer is my hand. Ah, that's good. Very good.
Yes, sir.
And okay, in this work somehow you can put subtract this from here to here. Actually, this mean is we can. Oh, we can directly do this here. Fine. So this, if you step from here to here, that will help actually. Easier. Otherwise, if you directly try to do here, it will little bit more calculation, but the answer will be same.
Sir, it is kind of similar to the formula that we had in class 12 probability. Mean rate.
Yeah,
Kind-
actually,
E
yeah.
of, E of x square minus mean का whole square.
Almost actually, no, the problem is that I know 50% student learn these things. And maybe not 50, maybe 40% or 30% student learn these things in class 10+2, but not all. But whatever I have taught first two classes, I know that 100% student learn that part. So that's why I have actually tried to finish as early as possible. But this part I need to go a little bit slow. Still, it is difficult. I need to more slow for normal distribution. Have you heard the normal distribution? Whatever this
No, sir.
Yes, sir. Gaussian.
Binomial
Yes,
distribution.
sir.
and Poisson that and binomial distribution?
Yes, sir.
Yes, sir.
Binomial we have
Yes,
Yes,
done.
sir.
sir.
Oh,
Poisson
that's good.
distribution.
Yes.
Oh, I thought binomial distribution you have not learned. That's good. Okay, so I can
Yes, sir.
go quick.
Binomial distribution.
So that's better. So no, okay. Let me skip these things. That means okay. Let us. Oh, this solution is not given. Can you do this one as early as possible? Only number 2, and I'm not going to more examples. Then we are going to binomial distribution. You try to solve this one. Just number 2.
Sir, can value of mean be negative?
Hmm?
Value of mean.
Sir, mean is coming 1 and variance is coming 2/3.
2/3. That's great. Yeah, that is correct. Very good. Who is talking?
Sir, me, Harsh.
Harsh. Oh, that's great. Yeah. So yes, actually some people learned. That's good. One assumption we have taken that random variable we are denoting. That's why I've said that some standard random is something like this. Then we are taking that no success. We are taking actually we are denoted it is the random variable is x equal to 0. And one success we are denoting a random variable x equal to 1, and two success with random variable 2. This is the standard way, but if you define different way, that is also fine. But
But
my
actually,
suggestion is
NP and NPQ formula.
huh?
NP and NPQ formula we are using.
Yes, sir,
That's
that
why
is
I'm
there.
going actually generalizing this formula. Wait, yeah,
Yes, sir.
that's correct. Those who know, then fine. Those who don't know, you need to go gradually. So you are able to do, is it? I hope you are able to do. If you don't do, your friend will help. So I am going, go forward. So some examples, okay, in this is actually I have added these examples, not given to you. I'll upload this one again. So this problem you will get, you try to solve these problems. So So let us come in the binomial distribution. This is new term for some students, and some students already know. That's great. Those who know, and those who don't know also fine. You will learn within 2 days or today also. So what we are doing here?
Sir?
Yes, please.
Sir, for any question, can value of mean become as negative?
For any question?
Sir, for any question means sir value of means.
Yeah.
Mean. So can it come as negative?
It may come negative. Yes.
Okay, sir.
Actually, the one thing is that your answer is if we answer your question with the online, the answer then may come negative. But our intuition that means whatever our real fact, generally we try to take it as a positive. In actually try to take as a random variable with suitable way. If we take the suitable way, it comes generally positive, but it can be negative. Yeah. Okay.
Sir, practically it is not possible for a mean to get negative.
Practically, it may be you can think it.
Question
Yeah.
mean can be negative.
Yeah. So.
Sir, because it is not the mean of data, random data. Is it probability mean? So that is why I don't think.
No. So okay, here you see the definition. Your question is nice question. So here mean means not here. We are multiplying by xk and probability of xk. Probability is lie between 0 and 1. That is fine, always positive. But this xk, it can be negative. That means we can define this random variable minus 0, minus 1, minus 2, minus 3, minus 4. In that case, it is always coming, all terms are coming negative. And if we do average, it is basically coming negative. But yeah, practical, and so in standard, if you find the average of the probability, that is always positive, it is fine. But here we are due to our some facilities later on, with some another variable we are introducing, we called it is random variable, and this random variable we can take is negative. So this average can be negative. So in this case, you see just the first example. Here you follow we random variable we were defined -2, -1, 0, 1, 2, 3, and instead of these three, if we suppose just one shifting like this -3 we have taken here, then it can be negative. That is some negative part is coming more, positive part is coming less. Okay. So practical situation, yeah, it can be if you think like that way.
That's
okay.
For negative case, it will have any special significance, or it is some any calculation.
No, it has some special significance. Yeah, because actually our target is this situation. So one thing, okay, that's good. Our target is actually we are trying to take out when data is huge. That means suppose 1 lakh, 2 lakh, whatever you did in 10 plus 2, you did only below data. That means maybe up to 100 or something like this. But if data is crore and crores, then how do we handle it? And what do we mean by this? So that's actually where our background in our mind is we should set as a formula, that is this type of formula, binomial distribution, normal distribution. In that case, we need to define like that way. That is our actually significant. We are coming on my own. Okay, let us start this one. So binomial distribution generally we do if our experiment is only two cases. The whatever we are experimenting, if one is success and two possibilities, either success or failure. In that case, we can use the binomial distribution. So any sample space where the sample space random experiment, suppose A event associate with a subset of A's such that the probability of A is P, and then automatically probability of non-A is 1 minus P. And this will denoted by P of A bar. A bar means outside of A. It is denoted by Q. And then, so we are getting probability of A plus probability of A bar is equal to 1, and that is actually P plus Q equal to 1. So, for example, it is tossing a coin or a true false question. That means you are marking tick. It is the probability, some probabilities they are true or some probabilities that false. So, if we know that probability, the true and false, then and if it is used, that means it is better, or it is not used, suppose it finite, that is 30, then it is some formula, so that this calculation we can do easily. That is our main target. So then we can write it, if we call it is the occurrence of an event A is success and a non-occurrence of an event is failure. Then we can write like this, probability of failure is equal to 1 minus probability of success. And that means this. So this line, basically this P plus Q equal to 1 means we can write like this, probability of failure plus probability of success is equal to 1. And in this case, according to table, so here we are taking the number of success. We are taking this random variable X as a number of success. So, and parallelly, we are trying to find the probability distribution. So, number of success may be 0, that means no success, maybe 1. Since we are trying to only one time, so this it can be either 0 success or 1 success. And what is the probability of 0 success? It is P. It is Q. And what is the probability of 1 success? It is P. Fine. Now, if we do this experiment twice, then what will be happen? So it is actually 4 cases can be happen. That is, same experiment we are doing twice. So it your output may be success. Your out may be success failure. Your output may be failure success, and maybe failure. These 4. So our target is, you see, we are going to just gradually or increasing. What will be happen? Since the trials are independent, so we can say that like this: probability of success equal to probability of success. Probability of both success. It is since independent, so we multiply for success into probability of success. So it is P square. And similarly, we can find this one: probability of success failure. It is PQ. You see, independent means this. Probability of failure success, we can write QP, and failure we can denote Q square. And so if we try to put in the table, that means like this, X is a number of success, it is, since we are doing twice, so success maximum can be 2. So actually number of experiment plus 1. So that we are getting, so no success, 1 success and 2 success. So what is the probability of no success? It is Q square, because both, that is this one, both are failure. And what is the probability of 1 success? 1 success, it is coming twice.
One success, one failure, one
Huh?
failure, one success.
Sorry? Any questions?
No,
Okay.
sir.
Okay. So here it is coming PQ 2 twice. So 1 success is coming 2 into PQ, and 2 success is coming P square. And the another thing is that here you see the summation of these probabilities is 1, keep in mind. And also in this table, also this summation of this probability is 1. This also. And this is actually, we can write like this way: the probability of X equal to 0 plus probability of X equal to 1, probability of X equal to 2. The distribution function we write. And this is actually like this. And it is, you see, this we are getting P plus Q whole square. So this is 1. And
Sir,
now,
sir, why we are taking failure success and success failure like in 2 different cases?
actually, we are experimenting first one. So it can be happen. The first one you are, so any experiment, it can be first one is success. Then second one is maybe failure. And again, first experiment we are just success. Second one is actually failure. So opposite can be happen actually. Since we are this experiment we are doing independently. First 2 cases, failure, success and failure. Second, another 2 cases, success and failure. So all combinations it can be happen any experiment. So we are considering all sample spaces. Are you getting it?
Okay, sir.
Okay. So now
So can you scroll up a little bit?
If we increase this experiment in 3 times, What will
Sir,
happen?
sir,
Yes.
Sir,
Yes. Yes,
sir,
please.
is that P of success into P of failure? Are those are independent events? Like we are multiplying the P into Q, right? But if the question may be given that if like when the die is rolled, if the 3 only comes, then he will be going to next step like that. If it is depending on the first event, then we don't allow to multiply directly because those are the dependent events, right? In this case,
No,
those
no,
are
no,
dependent
no, no.
events. We are
Same. No,
multiplying
no.
directly.
In this case, actually, we are considering same experiment we are doing twice. For example, we are tossing a coin. First, whatever happening, that's fine. And second one, not depend on the first one. If first one is head, then not depend on the second one. The probability is head will come more. So it is completely dependent. Same experiment we are doing twice.
Okay, sir. Okay.
Okay. And similarly, if we do the same experiment is thrice, what will be happen? So you can do that. The will come like this. Thrice means we can if we denote the random variable as a number of success, that means 0 success, 1 success, 2 success, and 3 success. Fine. So these 3 successes. And then the probabilities we can find like this. 0 success is q to the power 3. 1 success is 3q square p, and 2 success is 3q p square, and 3 success is pq. And you can see this equal to summation of this one equal to p plus q whole cube. So this is actually these coefficients are binomial coefficients. And similarly, if it is n times, the experiment same experiment we are doing n times. So it will come like this general case x equal to like this 0, 1, 2 dot it's in r n and any time. So it will come like this. So this coefficient n sus r written later on. Let's see first one. This n sus r means actually like this. You are some people are familiar with NCR. Okay,
Yes.
both are same notation. This is actually the standard.
Yes.
Okay. Now here, so this and so whatever intuitively you can do. So this binomial distribution, keep in mind binomial distribution. Whatever you have learned the general probabilities, almost all problem you can solve using your intuitively or previous theory. But this if you use this binomial theory, it will be easier. That means it will be easier and quickly. That is all. Nothing more it will give. But this binomial distribution, we are giving from binomial distribution, we are going to normal distribution later on or Poisson distribution. So these actually these are going. So we are trying to summarize this. In binomial distribution, we are taking if we experiment is n times and
And
is
we
n
get r
time out
time
of n
success.
times. If we take the success random variable random numbers are as a success of success of the experiment, then this we can summarize like this. The coefficient, this probability binomial random variable, we can denote like this. Is p of x equal to x such that this. So we need to remember like this. And why it is, we are clear about this coefficient. If k equal to 2, we are getting this one. So that's the general form we have written. Here 1 minus p means actually q.
For k time success.
For k,
Time success.
yeah, for k times success, exactly. Here it is written like this. For k times success, we are getting the probability of x equal to k. So this is the formula actually, just brief formula, something like this. In general experiment to this random variable. Okay. So this is the binomial random variable p of x is we denoted by this one. So this is the definition you can remember. So you need to remember this one, and I hope this is not difficult to remember also. And now we try to experiment this one. What is the mean? What is the variance? What is the standard deviation? We will try to. So parallelly, we are going to prove this one actually. Then if we take this binomial coefficient is this one, that means binomial random variable is this one. Then the mean is NP. We are proving later on. probably not today's class, next class will prove. And variance is this one. According to, if you put this formula in this formulas, the coefficient is here. This one, it will be, with some calculation we will get NP, and variance with some calculation we are getting this one. Okay, so this the binomial. I should say something about the Poisson. So one thing is that Poisson is not in your syllabus anyway, but I am giving because only shortly. So if it is infinite, so binomial generally, whatever this formula you have written, if it is finite case, n is finite, then this are doing well, and we can handle easily. But if n goes to infinite, what will be happen? Okay, and some case, some real cases is coming that this where success or failure, it is in infinite time, or infinite means it may be 5 lakhs. For example, suppose one any all India basis, suppose any exam means ground level exam, for example, or class 10 exam. It is uh, some people will success, that means pass or fail. So it is some crore students are giving this exam. That case, it is difficult to handle in binomial coefficient. So in that case, it is easier to handle in the Poisson distribution. So in infinite case, it is generally we are taking a Poisson distribution, but one condition is here. So if the probability is very less and the number of experiment is very high, that means we are multiplying this NP. So just here we have written our target is this mean is 1, but our target is this mean should be 1 and n should be very large, n should be infinite, and p is very less. Then we use this Poisson distribution, and we can easily find with some calculation. It is given in the Bavram's book also. You may see this after some calculation, this Poisson random variable is sends to this one when n is infinite. Poisson distribution, it is coming e to the power minus lambda to the power k over factorial k, where k is. And similarly, we can find the mean. Mean is actually lambda with some, okay, I have written here 1. It is not 1. We are trying to take it is some finite lambda. Our target is some finite lambda. So n is tends to infinity and p tends to 0, and this value is somehow lambda when this value is high. Then we will consider the Poisson random variable is this one, and the corresponding CDF function is this one, derivative of this. You can think.
Sir, what is the meaning of lambda here?
Lambda here actually we are taking some constant, that means average should taking some fixed average of mean. Okay, wait. You will if we give some example, I hope you are able to understand. And if we can calculate, we'll probably, I'm not going to calculate this one. This assignment is done actually. What is how we get this one? Now we get this one. So these two, so what I am saying that here, concluding this definition you need to remember, and also this one also need to remember. And using this one, we'll try to solve some problems. So let us check out one examples. So today almost time up. So where is the example? Huh? Oh, just 1 minute. Okay. So let us try to solve this one. Number 7. I hope you are getting. The incidence of occurrence disease in a industry, you read it and try to use this binomial coefficients or binomial distribution. We need to apply because you can do other way, I know, but if you habituated to apply this binomial distribution, then it will be easier for to solve other problems also. Number 7, anyone able to solve?
Sir,
Mm-hmm.
hello, sir.
Hmm.
Sir,
Yes,
4
please.
by 5, 4 by 5 to the power 6.
The answer is given here.
Oh,
Answer is given here. You try to. How do you solve? So here you see.
so the probability of success is 20%. That means 1 by 5. And probability of
1 by 5.
Yes, sir.
Probability
failure
1 by
is
5
4 by 5.
exactly.
Yes, sir.
Exactly.
And
That's up to that part is very good.
N is equal to 6, sir.
P equal to
Or
1 by 5.
n equal to
actually,
6.
we have to do 64, then 65, then 66, and
Yes, sir. 66.
binomial distribution.
Exactly.
Yes, sir.
Exactly. Yeah, that's correct. So let me just repeat what you have said. So here the probability given that 20%. That means here P equal to 1 by 5. So similarly, we can say 1 minus P equal to 4 by 5 or Q equal to 4 by 5, we can say. And let let P of X greater than 3. Denote the so here according to the question, what is the probability that out of 6 workers chosen at random, 4 or more will suffer from the disease? So it is, you can say that we need to find the probability of a random variable X, capital X, greater than 3. So that means actually we need to find probability of X equal to 4 plus probability of X equal to 5 plus probability of X equal to 6.
Yes, sir.
Okay. And that
Yes,
is
sir.
according to the binomial coefficient. You put these values, you will get the answer. And okay, I'm sharing this assignment again, new assignment. You can think. So you try to solve these 3 problems also. This
Okay,
So,
Okay, sir.
I'm
yes, sir.
sharing in MS Team. You can see from MS Team. After 5 minutes, I'm sharing. You can get
Sir,
it.
there is a problem in number 8.
Number 8, you try to solve this one. If you feel any problem, I'll discuss tomorrow.
Yes, sir. How can a probability be greater than 1, right? It's 15 written. I think.
Sir, it should be 1 by 5, I think.
Oh, it may be, yeah.
yes, sir.
Let me
Yes, sir.
say.
That would be 1 by 5.
Target is just 1 minute. The probability that a bomb dropped from a plane will strike the target is that's I have written wrong.
Yes, sir. That will be 1 by 5.
1 by 5.
Yeah, that will be 1 by 5. That's correct. Exactly. Thank you. I'm correcting it and I'm sending you. Okay. Thank you all.
Sir?
Yes. So 1 minute. I need
Sir, can
to
you
take.
explain?
Yeah, I should take attendance. Yeah, and so I finished my class. Those who want to leave, you may leave. And if you have any questions,